Hello everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 4, which is the Mechanics for October-November 2022, and the code is 9709/41. Okay, so let's move on to question number 1. So for question number 1, coplanar forces of magnitudes P newtons, Q newtons, 60 newtons, and 22 newtons act at a point in the directions shown in the diagram. The forces are in equilibrium, means that they are not moving. Okay, now find the values of P and Q. So for this case, I will be resolving the forces vertically and also horizontally. Okay, so from here, first of all, I will resolve the forces horizontally and towards the right side. Okay, so now from here, I will have 22 newtons. Okay, now plus this 16 newtons will be resolved horizontally, and it is in the same direction as 22 newtons. And now you are given 55 degrees. Therefore, I will be using 16 cos 55 degrees. Okay, and at the same time, this force P will be resolved horizontally, but it is in the different direction. Okay, therefore, it will be on the other side. So I will get P cos 25 degrees because the forces are in equilibrium, means that the left side forces will be same as right side forces. Then from here, I will get P cos or P equals to the total of the left hand side is basically 31.1772, and then this cos 25, it is same as 0.9063. So then from here I will be getting 34.4. That is my P. Okay, now to get the Q, I will resolve vertically, and upwards force is considered as positive. Okay, therefore from here, firstly you have the Qn is already the upward force, that is the Q, and it is positive because it's pointing upwards. And then now I have to resolve my 16n vertically, and then this angle, I don't want to use this angle, I'm going to use 55. So when you are using 55 degrees to resolve vertically 16 newtons, you have to use sine. Therefore, when I resolve 16 newtons vertically, which is in the same direction as Q, that will be 16 sine 55 degrees. Or probably you can just count what is the angle of that. So plus 16 sine 55 degrees. Okay, and then for the downwards force, I can just resolve this P vertically, and it is pointing downwards. So again, I'm going to use this 25 degrees. Therefore, it will be P sine 25 degrees. So here, since this is pointing downwards, so it will be balanced with the upward force. Then I will just write equals to P sine 25 degrees. Okay, then from here, to get the Q, right, now P sine 25 degrees, I will write 34.4 because we have counted 34.4 just now, sine 25 degrees. Then this plus 16 sine 55 degrees will be moved to the other side, becomes minus. So minus 16 sine 55 degrees. And at last, when you calculate this, it will be 1.43. So that's the solution for question number 1. Okay, so for question number 2, small smooth spheres A and B of equal radius and of the masses 6 kilograms and 2 kilograms respectively lie on a smooth horizontal plane. Okay, let's say this is the plane. Alright, initially A is moving towards B with speed 5 meters per second, and B is moving towards A with speed 3 meters per second. Means that here, this is the A, and here is the B. Okay. Now, your MA is 6 kilograms, and B is 2 kilograms. Right, so A moving towards B with 5, so means that UA is 5. Probably I label my A here. This is my A, this is my B. Okay, so UA is 5 meter per second, and then B moving towards A with speed 3 meter per second. So here I will write UB, it will be 3 meter per second. Now, after the spheres collide, both A and B move in the same direction, and the difference in the speeds of the spheres is 2 meter per second. So it means that now both of them moving on the same direction. So this is my A and B. Okay, since now from here we know that A is heavier than B and the speed of the A is faster than B. Therefore, it's expected both will be moving right side. So this is my VA and VB. Okay, so now given that the difference of the speeds is 2 meter per second, means that modulus of VA minus VB will be 2. And now find the loss of kinetic energy of the system due to the collision. Okay, so from here, first of all, I need to find out what are my values of VA and VB first by using conservation of linear momentum. Okay, so now before the collision, the momentum MA plus MAUA plus MBUB, it will be same as the momentum after the collision, which is MAVA plus MBVB. Okay, before we get the loss of kinetic energy, because kinetic energy involves the speeds. So therefore, just replace. It will be 6 times 5 plus 2 times. Okay, now be careful. Here I consider positive. Okay, here. This is positive 5 because the speed, the velocity, because the UA is basically the velocity. This velocity to the right side is positive. So now your B is towards left side. Therefore, where I write in the conservation of linear momentum formula, it will be negative 3. Okay, so be careful with this. Right? And then this is MA is 6, then VA plus 2VB. This is my first equation. Then from here, basically, you can simplify first before I label this as first equation. So for the left-hand side is 30 minus 6, which is 24. So I get 24 equals to 6 VA plus 2 VB. Okay, then from here, I will say that my VB, okay, so you just divide by 2. Therefore, this is 12 equals to 3 VA plus VB. This is my first equation. Okay, so from here, VA minus VB equals to 2, right? So I will say that it will be, you can say VA minus VB is 2, or the modulus of, it can be VB minus VA equals to 2 as well, up to you. Alright, so from here, I will just take the second one, VB minus VA is 2. So here, VB minus VA is 2. So this is a second equation. Then from here, basically, I can just find out what is my VB. So my VB is basically 2 plus VA. That is my second equation. So now you substitute second into first. So I will get 12 equals to 3 VA plus 2 plus VA. That is my VB. Okay, then from here, you will get 12 equals to 3 VA plus 2 plus VA, means that it is 4 VA now. So here I will get 4 VA. Therefore, 4 VA equals to 10. Hence, my VA is 10 over 4. That is 2.5. Okay, and then from the second equation, my VB equals to 2 plus VA. That is 2.5. Right, therefore I get 4.5. Okay, so that is the VA and VB. Another question asking for loss of kinetic energy. Alright, so now loss of kinetic energy, so I will just write kinetic energy equals to final KE minus initial KE, initial kinetic energy. So this is same as half of MAVA squared, because the kinetic energy is actually half mv squared, then plus half MB squared, then minus initial kinetic energy is half MA squared plus half MB squared. Okay, so then from here, just replace the values. The VA is 2.5 squared, and then the VB is 4.5 squared. So minus half of 6. The UA is basically 5, and UB is minus 3. Then from here, you will be getting 18.75 plus 20.25 minus 75 plus 9. Then here it will be 39 minus 84, end up with negative 45 joule. Because of negative value for the kinetic energy, therefore that is a loss. So loss of kinetic energy is 45 joule. Okay, now for question number 3. A constant resistance of magnitude 1400 newtons acts on a car of mass 1250 kilograms. A. The car is moving along a straight level route at a constant speed of 28 meters per second. Right? So find in kilowatts the rate at which the engine of the car is working. Now constant speed means that A equals to 0. Okay, A equals to 0, the V equals to 28. Now, basically, this is the diagram. Let's say this is a car. Okay, so resistance force means that let's say the car is moving to the right side. This is a driving force. So therefore, the resistance force will be towards left side. This is F equals to 1400 newtons. And now the M equals to 1250 kilograms. Okay, so now, first of all, before you get the rate at which the engine is working, that means this is actually the work done. Okay, this is the work done. Our work done formula is basically the force times V. Okay, but then here, because of the engine, so it becomes dV. So means that firstly I need to get what is my D, the driving force. So I will find the driving force using the Newton's second law. So now F equals to ma. Okay, based on this diagram, okay, so from here your V is 28, right? So your F is basically the driving force minus the resistance force. Then it will be the M is 1250, the A constant speed, therefore 0. That means from here my D will be just 1400 newtons. Right? Then after that, my work done, that is driving force times speed, that is 1400 times 28, and then you will be getting 39200 watt. And now the question asking for kilowatt means that you divide by 1000, therefore that is 39.2 kilowatt. So that's the answer for 3A. Now B, the car now travels at a constant speed up a hill inclined at an angle theta to the horizontal, where sine theta is 0.12 and the engine working at 43.5 kilowatt. That means this is the work done. Right? So then from here, Find the speed. Right, so this is a diagram. There's a hill here. This data, so sine data is 0.12. And this is the car. Okay, remember the car has mass 1250 kilograms. So this is the weight. And then here, driving force, D. Now the resistance force remains the same, 1400 newtons. Okay, and now the question asking for what is the V, the speed. Okay, given the work done has been changed. Now from here, and when you look at the question, again constant speed. So when constant speed means that the A is still 0. Okay, not speed constant, constant speed. Sorry. Alright, so now again I use the Newton's second law, F equals to ma. So now the direction, the D is in the same direction as the V. So I will write D. Then the rest I will just minus because they are in the different direction. So now first of all, when given this data, I know that here is going to be data. Okay, and now I need to resolve this 1250 grams along the plane. So when along the plane, it will be in the same direction as the resistance force. That means now here, since it is the resistance force and the resolve of the weight, they are in the same in the opposite direction of the D. Therefore, I have to minus both forces. So it will be 1250 G. Now, since I'm using the theta to resolve, and the theta is not the angle, okay, for the between the plane and also the weight, therefore I'm going to use sine. So this is your force after you resolve parallel to the plane or along the plane, then plus with the resistance force, then equals to the M 1250. Okay, again the A is 0 because of the constant speed. So from here, I will write D. Now, when you look at here, to find the D, okay, before you find the speed, you have to find the D first. This whole term will be moved to right side. Since the coefficient is negative, so when I move, it becomes a positive. So therefore, this is 1250. The G is replaced by 10, and sine theta is given, which is 0.12. Then you plus with 1400. So at last, this is going to be 2900. Okay, so now my driving force is 2900 newtons, and now you are given the work done is 43.5 kilowatt. So now the power, I would say power or work done equals to D times V. Okay, then here it will be 43.5 kilowatt. So 43.5 times 10 power 3 because of the kilowatts. So you have to times 10 power 3. That equals to driving force 2900. The V is the speed. So obviously the speed is 43.5 times 10 power 3 over 2900. Okay, so power is dF. That means here you'll be getting 15 meter per second. So it is not work done. Okay, I explained wrongly because work done is F times D. So this is power. Right? So same goes to this. This is power, not work done. Because of the rate. Rate of the work is power. Okay. Now, see, on another occasion, the car pulls a trailer of mass 600 kg up the same hill. The system of the car and the trailer is modeled as particles connected by a light by a light inextensible cable. The car's engine produces a driving force of 5,000 newtons. Okay, and the resistance to the motion of the trailer is 300 newtons. The resistance to the motion of the car remains as 1,400 newtons. Find the acceleration of the system and the tension in the cable. So there are two parts here. One is acceleration, the second is tension. Okay, so now let's say I draw the graph or draw the diagram. This is the heel. Okay, here, same here means that this is theta. So sine theta is 0.12. And then now here you will have the car. This is the car, the engine. Okay, now this is the driving force. The driving force of the engine is 5,000. So D equals to 5,000. Okay, then here you will assume that it is a light inextensible cable. After that, here you will have the trailer. This is a trailer. Okay, so now the trailer is 600 kilograms. So the weight is 600 G. Okay, then the car remains as 1250 G. Okay, then after that you have the forces. So if it is a string, you will have the T, tension. Okay, after that the resistance to the motion of the trailer is 300. So let's say here 300. This is a trailer, this is 300. And then the resistance to the motion of the car remains as 1,400. This is 1,400. Okay, so this is a diagram. Now, what to do here is you find the acceleration. So from here, we can just consider the second Newton's law. Okay, the Newton's second law for the car and trailer at the same time, or just consider whole system. So it's up to you. So let's say I consider the car and trailer. Then later I will tell you what to do for the system. Okay, so when I consider just the car means just this part. Alright, so when you consider here, the D is on the right side. I mean, the force pointing upwards, right? So it will be D, then the rest will be negative. So again, here, this is my theta. Wait, I draw longer a bit. And here is my theta. So now when I resolve the weight, right? So along the plane that is in the opposite direction of the D, and then I will have the T, I will have the 1,400. Okay, all this will be in the opposite direction of my D. So therefore I will get 1250 G sine theta, and then plus 1,400, which is the resistance force to the plane, to the car, and then the T. Okay, so then equals to MA. The M is 1250 A. So from here, I will just replace first. Now, the D is 5,000, so I have to replace the D by 5,000. Then from here, I will get 5,000 minus 1250 times 10 times 0.12, then plus 1400 plus T. Put a bracket. Then equals to 1250 A. Now to get the T, right, or from here, I will say that I open the brackets. For the left hand side, I will get 2100 minus T, because you times in the minus, right? And then here, right side remains at 1250 A. Let's say this is the first equation where I consider the car. Now when I consider the trailer, so again, from the trailer part, now you consider this whole part. Okay, here. Right? So my t will be pointing upwards. So it means that it will be t minus the rest of them. So again, here will be data. This is my data. So I will get 600 G sine theta plus 300 newtons. Okay, and then that's all. Equals to 600 A. So now from here, just replace first or times in the minus at the same time. So here I will get T minus 600 times 10 times 0.12, then minus 300, then equals to 600A. So when you calculate, this is going to be T minus 1020 equals to 600A. Okay, that is my second equation. So you can just solve these two simultaneous equations by adding both equations. So first plus second, because I noticed that your first equation has minus t, and then the second equation has positive t. So when I add up both, the t will be cancelled off. So from here, 2100 plus negative 1020, that is 1080. And then for the right side, 1250A plus 600A, that is 1850A. And then from here, my A is going to be 1080 over 1580, that is 0.5838. And I round up to three significant figures, that is going to be 0.584 meter per second squared. Okay, now once you have found the A, you can just find the T from the first or second equation. So now I will just substitute into the second equation. So my T equals to 600. The A is replaced by 0.5838. Then this minus 1020 will be moved to the other side, becomes plus. So this is going to be plus 1020. And then at last, you will be getting 1370. So that is your T, the tension. Okay, this is the working if you consider the car and trailer separately. If you need to consider whole system, right? So when consider whole system, the T here will be cancelled off. So no need to consider the T anymore. Right, because one pointing upwards and one pointing downwards. So what I do is I will just consider the rest of the forces. So from here I will get 1250 G. Alright, so from here, or this is another option. So or you consider whole system. So when you consider whole system, means that you no longer consider the car and trailer. So now I will get 5,000. Okay, this is the the force which is pointing upwards, and then the rest of them will be downwards. Right, the T will be not in the consideration, because when you consider the system, you are getting the A directly. So from here, I will just write 5,000 minus the rest. So it will be 1400, then 1250 G sine theta. So it will be 1400 plus 1250 G sine theta. After that, the T will be ignored. Then for the trailer, you will have 600 G. Okay, here is 600 G. Okay, so 600 G sine theta and together with the 300. Then now your M here, okay, again F equals to MA. So the M will be the mass of the trailer and also the car. So it will be 1250 plus 600, then A. Then from here you will be getting the A as this value. Okay, so this is the alternative method. So once you have found this, then to get the T, you have to consider either the car or the trailer. So you have two options to get the acceleration here. Okay, now for question number 4. A block of mass 8 kg is placed on a rough plane, which is inclined at an angle of 18 degrees to the horizontal. So the block is pulled up by a light string that makes 26 degrees above the line of greatest slope. The tension is T newtons. The coefficient of friction between the block and the plane is 0.65. Okay, since when you pull up, right, there's a tension here, means that it is expected to move up, right? Therefore, your frictional force will be pointing downwards. So, and then it's given that coefficient of friction is 0.65. This is 0.65 R. Okay, and here you will have 8G together with the angle. So this angle will be 18 degrees. Now, A, the acceleration of the block is 0.2 meter per second squared. So now from here, my A is 0.2 meter per second squared. Okay, and then find the T. Okay, so now, again, for this case, I need to resolve vertically and, parallel to the plane and also perpendicular to the plane. So now, this is my R. My R is always perpendicular to the plane. Then from here, when I resolve perpendicular to the plane, right? So firstly, I get R, and then together with the T. Okay, this T will be resolved upwards, but using 26 degrees, that is sine. So that means the forces perpendicular to the plane and pointing upwards will be R plus T sine 26 degrees. Then now it will be balanced with the mass. So this one resolve perpendicularly, right? But it is pointing downwards. And now since the angle is given 18 degrees, therefore it's going to be cos. So I will get 8G cos 18 degrees. So from here, my R is going to be 80 because the G is 10. 80 cos 18 degrees minus T sine 26 degrees. I let this be first equation. Now, when I resolve the forces along the plane, that means going up is considered positive, right? So now for this case, I will have T, and now I'm using the given degrees, given angle, which is 26 degrees. So it's going to be T cos 26 degrees, and then it will be balanced with the FR and also this 8G sine 18 degrees. Okay, so here I will just write my T cos 26 degrees. Okay, and then it will be, okay, then here. Alright, so now for your information, because it's sorry, it's mentioned that the acceleration of the block is 0.2. So now it will not be, when you consider the forces parallel to the plane or along the plane, you have to use F equals to ma, no longer balance with the left and right side forces, because if you use a concept of the first case, which is this, right, you resolve perpendicularly to the plane, that means the particle is not moving because it is balanced, which means it is in equilibrium, but actually the block is moving now. So therefore I will use F equals to ma. Okay, and then the forces pointing upwards and along the plane will be considered as positive. Therefore I will get T cos 26 degrees as positive, and then this FR will be negative, and this weight will be negative because they are in the different direction, or they are in the opposite direction of the tension. So now here I will write T cos 26 degrees minus total of the other two forces. So the frictional force is 0.65 R, and then the weight is Hg sine 18 degrees. Then my M, Okay, my M is the H, 8. Okay, because it's mentioned that the mass is 8 kilogram. So 8, the A is given 0.2. Okay, so from here, let this be my second equation. To get the T, so I will just substitute the first equation into second equation. That means now my T cos 26 degrees minus 0.65. My I is replaced by the first equation, which is 80 cos 18 degrees minus T sine 26 degrees. That's my R. Then plus this HG is 80 sine 18 degrees. The G is 10. That equals to 1.6. Okay, so now to get the T, I will group the T. And don't forget, okay, there is a negative here. So when you times in the negative, this term is basically plus. So since the T is in common, I can just take out the T. Then I will just write this is cos 26 degrees. And don't forget, this positive 65 must multiply to the T sine 26 degrees. So it becomes plus 0.65 sine 26 degrees because I have factorized a T. Then right side you have 1.6, and then now here, okay, look at here, this minus your times to the first term is basically minus, but then when I move to the other side it is positive. So here becomes plus 0.65 times 80 cos 18. Okay, and then again this minus, when you times into the last term here, it becomes minus. So when I move to the other side, it's actually a positive. So here is plus 80 sine 18 degrees. Okay, so for the left hand side, when you calculate the values inside the bracket, that is basically 1.1837, and then the total of the right hand side is 75.7763. Therefore my T is just a division of these two values. That is going to be 64.0. Okay, T newtons. So just write 64.0. That's it. So that's the solution of this part. Okay, now B, the block is initially at rest. At rest means that the U equals to 0. Now the distance, find the distance traveled by the block during 4th second of motion. 4th second of motion means that, let's say this is the T equals to 0 until 3 and then 4. Okay, 4th second is not 4 seconds, it's the 4th seconds, means that it will be distance traveled by 4 seconds minus distance traveled by 3 seconds. Alright, you need to find out what is T equals to S T equals to minus equals to 4 minus T, S T equals to 3. This is the meaning of 4th second. Alright, so now here, since it's involved U, S, and just now you were given the A. So the A was 0.2. Then I will just use the formula S equals to UT plus half AT squared. So when U equals to 0, that means now your S becomes half 0.2 T squared. That is going to be 0.1 T squared. This is my simplified distance formula. So now, distance traveled during the 4th second that is S T equals to 4 minus S T equals to 3. So now just replace a T by 4 and 3. So I get 0.1 4 squared minus 0.1 3 squared. That is going to be 1.6 minus 0.9. Then at last you will be getting 0.7 meters. So that is the requested distance. Okay, question number 5. A particle P moves on the x-axis from the origin O with initial velocity of -20. The acceleration A at the time t after leaving O is given by A equals to 12 minus 2t. A, sketch a velocity time graph for t between 0 and 12, indicating the times when P is at rest. Okay, so now we know that A equals to 12 minus 2t. So the A is basically dv dt. Alright, we know that A equals to dv dt. And now you need to find velocity time graph. You need to sketch velocity time graph, means that I need to get my v. So basically my v is integrate a dt, because that is a reverse process. So now my v is integrate 12 minus 2t with respect to time. And when you do integration, you are actually adding the degree. Let's say, okay, 1 degree of x. So now if I give you a x degree n dx, that is going to be a integrate x n dx. That is a x degree n plus 1 over n plus 1, then plus c. Right, where a is not minus 1. So there are two different formulas here. So now what to do is, the 12 becomes 12t, then 2t becomes 2t squared over 2, and followed by plus c. That means your v is basically 12t minus t squared plus c. But then it's mentioned that initial velocity of -20. That means when t equals to 0, your v is -20. The initial velocity is -20. So here v equals to -20. This is for you to calculate the c. Okay, so from here I will write, basically my v becomes 12t. Okay, I will just direct replace. -20 equals to 12 times 0 minus 0 plus c. Therefore your c is -20. Okay, so now my v is going to be 12t minus t squared minus 20. But now since you need to sketch this graph, so I better rearrange this, right? So it will be negative t squared plus 12t minus 20, and then I will factorize the negative. So you will get negative of t squared minus 12t plus 20. And this quadratic function can be factorized into t minus 10 together with t minus 2. So from here, I know the intersection points. Alright, now, and indicating the times when P is at rest. So it means that now, when V equals to 0. So now 0 equals to negative of t minus 10 bracket t minus 2, which means my t is going to be 10 and 2. When t equals to 10 and 2, the particle is at rest. Okay, so then now we need to calculate the velocity when t equals to 0 and 12. So t equals to 0 is already mentioned, it's already given. So I'm going to use this, t equals to 0, okay, and then this value for both t. And now, when you look at the interval, I need to calculate what is the value of v when t equals to 12, because your graph is up to t equals to 12. So now just do one more calculation. When t equals to 12, your v is negative of, just substitute into this. So it will be 12 minus 10 bracket 12 minus 2. That is going to be negative 20. Okay, and now I will sketch a graph. So this is negative 20. So then, okay, your v is negative 20. Let's say here minus 10 minus 20. Okay, then here 10, this is 20. This is your v, here is your t. T from 0 until 12. So I need to mark 2, 10. Let's say here 2, 4, 6, 8, 10, 12. So when t equals to 2 and 10, your v is 0. 2 and 10, your v is 0. So when v equals to 12, my t equals to 12, v equals to negative 20. Okay, and same goes to the initial velocity. It's also negative 20. Now I know that the graph, it is a quadratic because it's negative here, so it will be in this shape. So now I need to find out what is my maximum value, maximum V. So look at here, this is each unit. So each unit, because the quadratic curve is always symmetrical, so it means that each unit you divide by 2, that is 4. So 4 units from 2, that is 6. So it means that the maximum velocity happens at t equals to 6. So now I need to calculate what is my v. So when t equals to 6, my v is negative of t minus 10, so 6 minus 10, and then 6 minus 2. So from here, you will be getting 16. Okay, so now I know that my velocity is at 16. So roughly sketch, probably here, this is my 16. Okay, then now just join the points to get the quadratic curve. So this is my velocity time graph. Okay, now B, find the total distance traveled by P in the interval 0 to 12. Okay, so now the total distance is basically okay, V equals to ds dt. So now your S is integrate V dt. So now I need to do integration. So when integration, that means that is the area under the curve. So obviously from here, from 0 to 2, the region is negative because it's below the x-axis. So my integration must put modulus. Same goes to 12, 10 to 12. The region is below. But then for 2 to 10, I can just direct integrate. So now I will split it into 3 integrations. So my distance is modulus from 0 to 2, and then 12t minus t squared minus 20 dt. The middle one, it will be just direct integrate 2 to 10, 12t minus t squared minus 20, and then lastly plus modulus 10 to 12, then 12t minus t squared minus 20. Okay, I split it into 3 parts because of 3 different regions. So from here, when you integrate, the first one is 12t squared over 2. Okay, probably I just write. Minus t cubed over 3 minus 20t. Same integration for all, so just rewrite. So basically, the first one, 12 over 2 is 6. So I can just direct write 6t squared. Okay, then from here, just replace the values. So I will get modulus of 6, 2 square minus 2 cubed over 3 minus 20 times 2. Then when t equals to 0, everything is 0. So I will just write minus 0 plus 6 times 10 squared minus 10 cubed over 3 minus 20 times 10 minus 20 times 10. Then you minus when it is 2. Okay, so then here I will write minus, put a bracket, when the t is replaced by 2. Then the last Last one will be the same, just replace. Okay, replace the t by 12 first. So I'll get 6 times 12 squared minus 12 cubed over 3 minus 20 times 12. Then you minus, put bracket here, then minus when it is 10. Put a modulus. That means now you will be getting modulus of negative 56 over 3 for the first part because you minus 0. And then the middle one will be 200 over 3 minus negative 56 over 3. No need to calculate, just copy from the previous part. Plus modulus of 48 minus 200 over 3. Put a modulus. That means here you will be getting 56 over 3 after the modulus. Then the middle value is 256 over 3. And then the last one will be modulus of negative 56 over 3. Okay, that is going to be positive 56 over 3. Then at last you will be getting 368 over 3. So this is the total distance. Okay, so for question number 6, figure 6.1 shows particles A and B of masses 4 kilograms and 3 kilograms respectively, attached to the ends of a light in extensible strings that passes over a small smooth pulley. The pulley is fixed at the top of the plane, which is inclined at angle of 30 degrees to the horizontal. A hangs freely below the pulley and B is on the inclined plane. The string is taut and the section of string between B and the pulley is parallel to the lines. Okay, now A, given that the plane is rough, the particles are in limiting equilibrium. Find the coefficient of friction between B and plane. So firstly, from here, I will expect the A moves down, okay, by A, acceleration A, and this, the weight is 4g. Then the B will moving up, okay, then with the same acceleration. And now here, since the plane is rough, I will have the frictional force. This is Fr equals to mu r. So the R is perpendicular to the plane. And then for the weight of the B, this is 3g. Now, you have the string, this is T, tension, this is also T, tension. And now here, the angle 30 degrees corresponds to this 30 degrees. Alright, so now, to find the coefficient of friction, because it's mentioned that limiting equilibrium means that the whole system is static, it's not moving yet. Therefore, I will just resolve two particles A and B. So now, for the particle A, obviously T equals to 4g. Okay, so now here I will write A, T equals to 4g. Then, this is basically 40, right? Because your G is 10. Okay, then from here, my particle B, you have to resolve. So for particle B, the R itself, I consider the R first. The R is basically 3g cos 30 degrees. So R equals to 3g cos 30 degrees. It is 3 times 10. Cos 30 is square root 3 over 2. That means you are getting 15 square root 3. We found the R. Okay, now, when I consider F equals to MA, right? So, F equals to MA. Since this is equilibrium, means that your A equals to 0. Okay, then from here, I will just consider this direction. I mean the direction which is parallel to the plane. Now, for the T, this I'll consider the part B here. Okay, so T, it is the force pointing upwards, and then the rest, these two, will be pointing downwards. So it will be balanced because limiting equilibrium, right? So A equals to 0. Therefore, I will say that the upwards force is balanced by the downward force. So therefore, I will get T equals to, now downward force is Fr. Fr is mu r. So here I will write mu r plus 3g. Now when I resolve this 3g parallel to the plane, that I'm going to use the 30 degrees, but 30 degrees is not the angle over here. It's the alternate angle. Therefore, that is sine. So it will be 3g sine 30 degrees. Okay, and now T is found 40. The mu is not known because you need to find mu. The R is found 15 square root 3. Then plus 3 times 10 sine 30 is half. Then from here to get the mu, right, I will say I keep this here and all this move to the other side. So that is 40 minus 3 times 10 times half. Then divided by, or I keep this first. I do step by step first. So 3 times 10 times half is actually 15. So 40 minus 15, that is 25. Hence, your mu is going to be 25 divided by 15 square root 3. That is 5 square root 3 over 9. This is your coefficient of friction. Okay, now for part B, it is given instead that the plane is smooth, so no more frictional force, and the particles are released from rest when the difference in the vertical heights of the particles is 1 meters. Okay, so here, this is 1 meters. I use an energy method to find the speed of the particles at the instant when the particles are at the same horizontal level. Okay, so from here, basically we have two methods to solve this question. First is I refer to this as the reference line. Let's say this is the reference line. Alright, so I will expect A to go down, the B go up. This is the T. Okay, and here you have 3G. This no more R. Okay, remember no more R. Now initially released as rest means that U equals to 0 for both. Alright, and now here I will have to define first, because when they are in the 1 meter away from the A and B vertical distance, so I will assume A has travels down for X centimeters. Okay, because the question asks for when the particles are at the same horizontal level, means that now the A will goes down. Okay, will goes down. Okay, and then the B will go up. So it will be at the same horizontal level. That's why I let this be X. Okay, and then I will let this be Y. Clear? So now I will define first. Let A traverse down for X meters. So when it travels down for X meters, that means then B travels along the plane travels X meters along the plane. Okay, because of B lies on the plane, so it will be go up here X meters. Alright, so it's just that now the X meters I have to consider vertical plane, vertical distance. Okay, so from here, height of B from initial position Y, I let it be Y, then this is going to be, because now your X is the vertical distance, so now my Y is the vertical distance. So when you resolve, remember here is 30 degrees. Right, so now, or I will say that this is 30 degrees. Look at here, this is a triangle. Okay, so that means here is 30 degrees. So now when you look at this triangle, here is 30 degrees, this is your y, okay, and this is your x. So which means sine 30 is sine 30 degrees equals to y over x. Therefore your y is x sine 30 degrees. So here I will write x sine 30 degrees. Okay, so and they are 1 meter away, vertical distance. That means x plus y will be 1 meter. So here I will just write x plus y equals to 1. Therefore x plus x sine 30 degrees is 1. So this is x plus half x, which means 3 over 2x is 1. Therefore my x is basically 2 over 3. So which means, okay, my x will travel down for 2 over 3 meters, and then my b will travel up 1 over 3 meters vertically. So therefore my y is 1 over 3. Okay, why do I need to find out all this? Because you consider the energy later on. So energy, we need to get the gravitational potential energy, which is mgh, which is the vertical distance from the reference line. Okay, so that means now here I know that this is 2 over 3. This is 2 over 3 meter, and here is 1 over 3 meter. Okay, so now with this I will consider the conservative of energy. I will consider the conservation of energy method. I will refer to this method. Okay, so for the particle A, my initial GPE, gravitational potential energy, that is mgh. So for G, initially, because I'm referring to this as initial line, so initially the height is 1. So 1. Okay, so initial KE, kinetic energy, since both are not moving, 0. So then the final GPE. Now, when you refer to this reference line, the x is 2 over 3, but then since this is a reference line, means that you are counting the h from the reference line. That means the h is actually 1 over 3. Okay, so here 1 over 3. Then the final kinetic energy, that is going to be half mv squared. The m is for v, do not know. Now for the particle B, it's the same method. Initial GPE, that is 0, because the B is on the reference line. Therefore, the vertical distance is 0. And then the initial kinetic energy, both are at rest. Therefore, 0. Then the final GPE, final gravitational potential energy. So again, this is counted from the reference line. What is the h? So the h is 1 over 3 and the m is 3. So I will get 3g times 1 over 3. Then now the final kinetic energy, that is half times 3 times v squared. Okay, since they are connected by the string, so the v for both particles will be the same because they are connected by the same string. So then from here, I will just write, okay, so from the conservation of energy, the initial mechanical energy equals to final mechanical energy. That means initial gravitational potential energy plus initial kinetic energy equals to final gravitational potential energy plus final kinetic energy. So just consider both particles A and B now, okay, for the initial ME and final ME. So now initial ME, it is 4 grams, 4G, not 4 grams, 4G times 1. because the rest are 0. So I will just write 4G. So 4G equals to final GPE plus final KE. So final GPE, 4G times 1 over 3 plus 3G times 1 over 3. 1 over 3. And plus final KE, kinetic energy, half times 4V squared, half times 3V squared. So then from here, I will get 4 times 10 equals to, this is 4 over 3 times 10 plus the 3 and 1 over 3 cancel, you get G. Okay. Then the half and 4 cancel, you get 2. Then this remains. So I'll get V squared plus 3 over 2 V squared. Okay. So from here, you will get, for the right side, 1 V squared plus 3 over 2 V squared. That is actually one. Okay, I don't write this. I don't cancel it, then it will be easier to calculate. Then here will be half times 4. So 4 plus 3, it will be 7. Right, 7 over 2. So here I will get 7 over 2 V squared. So then for these 3 terms, okay, so these 2 terms you just move to the left side, then you will be getting, this is 40, 40 minus 10 is 30, 30 minus this value, that will be 50 over 3. Okay, then your V squared is going to be 50 over 3 times 2 over 7. Then you will get 100 over 21. So then to get the V, just take square root. So your V is square root 100 over 21. That is going to be 2.18 meter per second. So that is your speed. Now, actually, we have another method which is using different reference line. Okay, so here I use this as reference line, and the second method is you can use this as your reference line. This is the second method. This is the reference line. So if you use this as a reference line, right, the difference is the H in your PE, initial PE. So if initial PE for the A, it becomes, the height is 2 over 3. Okay, but then for the B, because it is below the reference line, so the H becomes negative 1 over 3. So that's the difference. So now I will show you the second method, which is using the orange color as a reference line. So now, okay, so for the A, initial PE, it will be mg, the H is 2 over 3, because now you refer to the orange reference line, right? It is 2 over 3 above the orange reference line. Therefore now the KE remains as 0. So now the final KE, final GPE. So for final GPE, right, because we know that the A will move down 2 over 3 units, that means at last it will be here. So the final GPE will be 0 because the H is 0. Then the final kinetic energy, it will be half 4V squared. So for the particle B, the initial GPE, that is going to be at first, right? So it is 1 over 3 meter below the reference line. Therefore, the H is negative 1 over 3. So I will write 3G times negative 1 over 3. Then the initial KE will be the same because both at rest. Then the final GPE. Okay, so final GPE for the particle B, because it will reach here, right? Therefore, the GPE will be 0 because it is on the reference line. So here I will just write this is 0. Then the final kinetic energy will be half times 3 times v squared. Alright, so from here, just substitute into the same formula. So now, initial KE, I write initial ME equals to final ME. Okay, just plus these two together for the initial mechanical energy. So I will get 4g times 2 over 3 plus 3g times negative 1 over 3. Then final mechanical energy, just plus these two values. Half times 4 v squared plus half times 3 v squared. So for the right side, you get 4 plus 3, 7 over 2. 7 over 2 v squared. For the left hand side, because of 3 and negative 1 over 3. Okay, so here is basically negative g. So I will get 8 minus, so 8 over 3 minus 1 over 1g. Okay, 8 over 3g minus 1g. That is going to be 5 over 3g. Then now your v squared, it will be 5 over 3. G is 10. After that, you move the 7 over 2 to the other side, becomes 2 over 7. Then now you will be getting the same answer, which is here. 50 over 3 times 2 over 7. Okay, then you will be getting 100 over 21. And at last, your V is going to be square root. That is 2.18. Okay, so that's the second method to solve this question, whereby we are referring to the orange line as the reference line. Okay, so we have two options to solve this question. Okay, so I have come to the end of the video. Thanks for watching. Please like and subscribe to the channel, and also share this channel with your friends if you enjoy watching my video. And also stay tuned for more upcoming videos. Thank you everyone. Bye.